In this tutorial, we're going to take a look at some connections between tables of values, what are called first differences or rates of change for a linear relation. So we're going to take a look at, and there's no particular reason I used this equation. I could have used lots of different equations, but this is the one I chose to use. So the equation here for this linear relation is y equals 2x plus 1. So we're going to make a table of values first here, and I'm going to talk about the x values first. I chose the numbers -3 to +3. You can really use almost anything you want here, but we generally see what's called sort of the more interesting part of the graph if you select a few numbers that are negative, a few numbers that are positive, and somewhere close to 0. There are some exceptions to that, but that's a fairly good rule for starting with tables of values. And sometimes you might make a table of values and realize, oh, well, actually, I think I'd like to have some extra numbers that are a little bigger positive or a little bit smaller negative, and then you can modify that afterwards. So to calculate each of these y values, I'm going to substitute the -3 in place of x here for the very first one. So when I do that, you see instead of x here I have a -3, so I go 2 times -3 plus the 1, that's the plus 1 there. Now that's -6 plus 1 gives you -5, so this y value would be -5. In my calculator, I could just type in this, 2 times -3 plus 1, and so that gives -5. That's -6 plus 1 gives you -5. The next one would be, we'd put a -2 there, and so that's going to be -3. See, this would be -4. Remember, BEDMAS, you multiply before you add. So that's -4 plus 1 gives you -3. So now, I just plotted the point here. This is actually the point -3 comma -5. So we go left 3, down 5. So that's the point -3 comma -5. So next one, the one I just showed in the calculator, we're putting the -2 in place of x here now. So 2 times -2 is -4 plus 1 gives you -3. So this can be -3. So this is the ordered pair -2 comma -3. So -2, -3 would be right here. So we plot that point. And then we do -1. So we'll put a -1 in place of x. That's -2 plus 1 works out to -1. So this would be -1. So that's the point -1 comma -1. So that would be left 1, down 1. So we'll plot a point right there. So next we'll put 0 in place of x. So that works out to 1. So the point 0, 1 would be this one right here. Remember, 0 means you don't go right or left. You just go up the 1 then. So let's put 1 in next. 2 times 1 is 2, plus 1 works out to 3. So the next y value is 3. So 1, 3 would be right here. And so 2 next gives you 5. So put a 5 here. And plot 2, 5 would be right there. And the last one, putting 3 in, 6 and 1 add to 7. So that's a 7. So this is going to be the point 3 comma 7. So 3, 7 would be right there. And we draw a line between them. So notice that this produces a nice straight line. Now, I duplicated the table of values down here because I want to talk about what are called the first differences. And the first differences are what y is changing by in the table. As we go from -3 to -5 to -3, what is the change? And the change there is it's going up 2. If you think of a number line to go from -5 to -3, you're going closer to 0, you're going up by 2. What you actually, if you want to do this in the calculator, you take the bottom number, like the second number, -3, and we're going to subtract -5 from that. And so that works out to +2. So that's the same as -3 plus 5. We get a double negative here. -3 plus 5 gives you +2. So 2 is the change from -5 to -3. From -3 to -1, it's going up 2 again. From -1 to +1 is also going up 2 again. From +1 up to +3, it's going up 2 again, and they're all 2. So 3 to 5 goes up 2, 5 to 7 goes up 2. So notice that the first differences are all changing by 2. Now, what I'm going to draw, and actually notice I didn't put it on the graph because the x's are going up by 1, but these are actually all changing by 1. I didn't put them here, but -1 to 0 changes by 1 because I chose successive values. These are actually all 1s. So what this little triangle here is going from this point to this point. It's going across 1 and up 2. And then to go from this point to the third point, it's going across 1 and up 2. So we go over 1 and up 2. And see, x is changing by 1 every time. The y value is changing by 2 every time. So all the changes are the same. So this goes over 1, up 2, over 1, up 2, and it does it the same every time. That's why it's a straight line. Because every time we go over 1, y is going up by the same amount every time. Now if we enlarge this graph, so I'm enlarging just around sort of those the last 4 points. This is actually the run, the change in the bottom here, the change in x, and this is the rise here. Another way to write the change in y and the change of x, the first difference is the change in y. The Greek letter delta is a little triangle, represents change in y. This is the change in x here. So this is actually called delta x, all these ones. So remember, slope is rise over run. That's supposed to be an R there. Another way to write that formula is instead of rise and run, you can call the rise the change in y, because it's how much the y is going up, and the change in x, the run. So that's another way to write the slope formula. So that's just some connections between the tables of values, the first differences. If the first differences are the same, then you always get a nice straight line like this. When the first differences aren't all the same, it's never going to be a straight line. It'll start being some kind of curve. And that's the end of the tutorial.